a network layer protocol that is used to do something which I am going to tell you. ARP stands for Address Resolution Protocol, and RARP is Reverse Address Resolution Protocol. These two protocols are very helpful for certain reason. So you see that what happens, how do the network layer and the data link layer, how do they work hand in hand? So you see that, so forget about this for now. So just imagine, don't look at the slide, just listen to what I say. Let us say that, so we have two addresses, right? So we have the logical address, which is the IP address, and we have the MAC address, right? We have, which is called the physical address also. So we have two addresses. So this logical address basically operates, the IP address operates in the network layer, and the physical address, basically this MAC address, operates in the data link layer. So we have two different addresses. Now we also know the purpose of these two addresses. We know that what is the purpose of the the IP address. We know what is the purpose of the MAC address, and in a previous class I had shown you what is the format of the MAC address, right? So using colons, right? So you have typically the MAC address is given in hexadecimal form, whereas the IP address is given in the decimal form with the dotted notation, and the MAC address basically, these numbers are basically, these hexadecimal values are separated with colons. So anyways, so those two are basically the ways they are represented, but the main thing is that one works in the network layer, that means the IP address works in the network layer, and the MAC address basically works in the data link layer. Now both are required, right? And we have seen that both will be required, why these are going to be required. Now if both are required, sometimes it might be possible that you want to send the packet, so let us say that you have some packet, you means who, some host, right? So some host has some packet, and the host knows the IP address of the destination. The host knows the IP address of the destination. So what can it do? So what does the host know? No, it knows the source IP, that means its own IP. Obviously it also knows its own MAC address, there is no problem with that. But if that destination is not within the same network, it is quite likely that it will not know the MAC address of the destination. So if it doesn't know the MAC address of the destination, how it can find it? How can it find it? Because ultimately the link layer, both the link layers, the peers, they are going to talk using the corresponding MAC address. So how can it find the corresponding MAC address? So for this, basically this ARP protocol has been designed, which can help in finding the corresponding MAC address of the link layer address. So this ARP basically accepts the IP address from the IP protocol. It maps the address to the corresponding link layer address, and then it passes to the data link layer like this. So this is what is shown over here. The IP, so this is the network layer. This ARP protocol is a network layer protocol. What does it do? It takes the IP address and it sends the data, right? So to the link layer, right? Because ultimately, it needs to help in finding the corresponding link layer address for a remote destination node. So let us now, this is the most important part. So please pay attention over here. So how does this ARP protocol, how does it operate? So anytime a host or a router needs to find the link layer address of another host or router in its network, it sends an ARP request packet. So this is the first thing that it is going to do, right? So let us say that you have a system, some host A, it wants to send some packet to host B, right? So what it is going to do? It is going to take help of the ARP protocol in order to understand what is the MAC address of this one. So you see that this particular host, it knows its own logical address N1, it knows its own link address L1, that means the MAC address L1. It knows the destination IP address, but what it doesn't know is the destination link address or the MAC address. So how does this ARP protocol basically help in doing it? So this particular ARP packet, it will include, that is sent from here, some request packet is going to be sent, right? So ARP request packet like this, it is going to be sent, right? So this packet basically is going to include the link address, the IP address of the sender, that means system A, okay, and it is going to broadcast it. It is going to broadcast it. So if it is within the same network, what is going to happen is all the other hosts, so they are also going to receive it. So because the sender doesn't know the link layer address of the receiver, this particular query request is going to be broadcast over the link using the link layer broadcast address. Now everybody knows the broadcast address, if ff colon ff like that, so that's the broadcast address, right? So it is going to broadcast, right? So if you look at, so this request that is going to be sent, okay, it is going to have 4 parts. So it's going to have N1, it's going to have L1, and let us say that it is looking for L2 and N2 is known, right? It is looking for L2, N2 is known. So what it is going to do is N1, L1, 2 parts are already filled in the request. N2 is also filled in that particular request. The only thing that is not filled is basically this L2. So we need to know. So let us put a question mark in that field L2. So first, what it is going to do? It is going to send a broadcast. So you write the corresponding broadcast address. So the corresponding broadcast address, like ff colon like that, so that's going to be the broadcast address. So it's going to be broadcast. So basically, whenever all the links that are connected in that particular network, all the other hosts that are connected to that network receive that particular broadcast message. So it will look at the intended destination IP address, which is N2. So N4 knows that, so this request is for looking for N2. So N4 is not going to, this particular host it is going to discard it. This particular host is also going to discard it, and only, so this host, it knows that, the destination address N2 is mentioned over here. Please, all of you, keep yourselves on mute. So only N2 is N2 knows that, so this particular request message, the ARP request message, is meant for it, right? So what it is going to do? It is going to send a response back. Now, how this response is going to be sent back? So this response is going to be the reply, ARP reply is going to be unicast to the source, because it knows that which particular node has requested it. It knows that the node with or the host with address N1 has requested it. So it is going to do what? It is going to send a unicast reply. Why unicast? Why? So the why here it is broadcast, and why here it is unicast? So let us take an analogy over here. Let us say that I am in the actual classroom, right? And in the classroom, I want to know who is a particular student. Who is a particular student? X. Let us call him X. So who is a particular student X? So what do? I broadcast this message. I ask in the class. I ask like, who is X? Then whoever is not X is not going to respond, but the student whose name is X is going to say that I am X. So the student is going to tell directly to me that I am X. So very similar to that. So that is the reason basically this ARP request is broadcast, whereas the reply is unicast to the source. Is it clear? Any doubt? So I hope that this is the crux basically, right? So this is how ARP operates, and this is the crux, and so if you have understood this, then most of it you have understood. The rest of the things like ARP packet structure, etc. So please go through yourself. So you see that apart from all these different fields, there is also the source hardware address, source protocol address, destination hardware address, and this. So this is what I was telling you. This ARP packet, right, that is going to be sent, or the response also the same thing. Basically, it has the source IP, the source MAC, destination IP, destination MAC, right? And when you do not know the destination hardware address and you are broadcasting, fill it out with the broadcast address, the default broadcast address. Okay, so go through it, and then you will be able to so this thing you need to really so you need to go through yourselves, and you need to convince like why these different fields are there. So let us try to understand a little bit in further detail that we have a host with IP address N1 and the MAC address L1, and it has a packet to send to another host with IP address N2 and MAC address L2, which is unknown to the first host. Obviously, initially it will be unknown. The two hosts are in the same network. So the ARP request and response messages, exactly the same thing that I have explained to you so far. So you see, this is the scenario that is given to you, right? And so this particular A is going to communicate with B. So A doesn't, A knows N1, L1, obviously. A also knows N2. So unknown is L2. So how that is going to be resolved with the help of this ARP request. So you see that L1, N1 and N2, these are the different fields of the ARP request packet, right? So here, this is N1, L1 and N2, and this is the L2, right? So now initially, if it is a broadcast request, the broadcast corresponding broadcast address is going to be filled in over here, right? So I told you that in hexadecimal it is FF:FF like that, and in binary actually it is going to be all zeros, right? So like this, that broadcast packet is going to be sent, right? And finally you are going to get the unicast response back from B to A. This is how this broadcast broadcast message is sent out, and this node N2 basically it is going to send a unicast back to the source. Okay. So an ARP packet is basically encapsulated directly into the data link frame. Okay. So into the data link frame, basically it is going to be encapsulated. So encapsulated means what? That this particular frame, the ARP frame, so ARP packet is received from where? From which layer? From the network layer, right? So this ARP protocol is a network layer protocol, so which so that particular packet that is sent out, that request or the response or whatever, it is going to be passed to the link layer. The link layer is going to encapsulate that ERP packet, and now it is going to follow the link layer protocols as usual. So this is pictorially shown over here. ERP request or reply packet becomes the payload or the data, and the rest of the frames. So if it is Ethernet, the corresponding frames, etc., are going to be like this, and it is going to be sent. Okay. Now this ERP packet and the corresponding operations, basically these 7 steps of operations, which actually I have told you already. This is this is mentioned over here. Please go through it carefully. I am not going to repeat the same thing I have already explained to you, but please go through carefully and try to understand how these ERP packets are going to be operated in that network. So remember that ERP packet is generated by the network layer, passed on to the link layer, and this link layer is going to encapsulate it using the other fields inside the frame. So this ERP packet is going to be the actual data or the payload of that of that link layer frame, and it is going to be sent on to the other side, right? So there are 4 different cases that can happen. Okay, case 1, the sender is a host and wants to send a packet to another host on the same network. Okay, like this. So regular. So in this case, the logical address that must be mapped to a physical address is the destination IP address in the datagram header. So like this. Okay, so this is simple. Now case 2, the sender is a host and wants to send a packet to another host on another network. So this was in the same network, but so it is in another network. You see that because it is another network, it is replaced over here by the host is replaced by a router, right? So in this case, the host looks at its routing table and finds the IP address of the next hop. Now you see the next hop is going to be what? The router or the default gateway, okay, for the destination. If it does not have a routing table, it looks for the IP address of the default router. It is going to be sent to the default router, right? If the IP address is found, it is going to so it is going to send to that particular router or so wherever it has to send. I mean, obviously, it has to, if it is a different network, then it has to send it to that router, whether it is a default one or not. The IP address of the router becomes the logical address that must be mapped to the physical address. Okay, so you see that the sender basically, it is going to take in segments, right? So from it to the immediate, because it's going to go to another network. So this router is going to act kind of like a proxy for the host in the another network. So this router is going to act like the proxy for it. So basically this link layer address of this router is going to be sent to the sender. Now case 3, the sender is a router that has received a datagram destined for a host on another network. Okay, so the router, basically the sender is a router, the router receives it. So from router it has to be sent to another router. So what it will do is it will check its routing table and find the IP address of the next router. The IP address of the next router becomes the logical address that must be mapped to the physical address. So the essence over here is that you see that whether it is host to host directly or host to router or router to router, and the next case is basically router to host, the entire spectrum is basically captured. But the main thing is that however way you are connected, you follow exactly the same approach that I mentioned to you in terms of the operation of the ERP protocol. Exactly the same thing you follow, right? So the only thing is that in some case the destination is going to be a host, in some case it is going to be a router. So, and all these different possible scenarios can happen, sender to host, sender to router, router to router, and sender to, sorry, the router to host. So all these different possibilities can happen, but exactly the same process that I said applies over here. So you see that a router basically acts as a proxy ARP router. So a proxy ERP running in a router can respond to an ERP request for any of its protocols. The proxy ERP relies on its own MAC address. When the packet arrives, the router delivers it to the appropriate host, right? So the router, it's going to follow the same thing. So once it receives it, it's going to send to one of its hosts, right? So a request from a router or a host arrives. Okay, so all of these people, they can get, and when it comes to the router, basically the router is going to do the same thing, and it's going to send to the corresponding network. Okay, so the packet format basically, so how, so you please go through all of these. The one last thing that we are going to talk about before I end over here is, so before I begin this ERP protocol, any question on the ERP protocol? So everybody understood how the ERP protocol functions? Now, the last thing, and then we will stop for today, the RARP. So RARP stands for Reverse Address Resolution Protocol. Okay, exactly what you did. So if you know the link, if you know the logical address, the IP address of a remote host or a router, you can get its corresponding link address using ERP protocol. The RARP does the reverse, that if you know the physical address, how can you get the corresponding IP address? So if I know the physical address, let us say that I have purchased a machine, and I know obviously the physical address, which is the address of the NIC card, the network card, right? So how can I get the corresponding IP address? So for this, basically, the protocol previously which was used was the RARP, Reverse Address Resolution Protocol, which has been kind of replaced with the DHCP protocol nowadays, right? So you will not see much of RARP being used. It is the DHCP protocol, but this DHCP protocol, the way it gives you the IP address, it uses some concepts from RARP. It is inspired by the functioning of the RARP protocol. So based on the computer networking which is employed by the client computer to request its IP address from a gateway server's address resolution protocol. So this is how it works. The network administrator creates a table in the gateway router which is used to map the MAC address to the corresponding IP address. Okay, so let us say that you have a computer and you know what is the MAC address for it. So the question is that if you have to connect to the internet, you need to know the corresponding IP address. So this RARP protocol basically can help you to do it. Okay. Now there are different operations of this RARP protocol. Okay. So the source device basically generates the RARP request message first, right? Then the source device basically broadcasts the RARP request message. The local devices basically process the RARP request message. The RARP server generates the RARP reply message. The RARP server sends the RARP reply message, and the source device basically processes the RARP reply message. So these are the operations, very similar to how the ERP works, but it's opposite now, right? It's opposite now. So that is why it is called the reverse ERP, right? So, but exactly the same kind of broadcasting and unicasting, broadcasting of the original request and the unicasting of the reply. So that thing basically is there in RARP as well. So the corresponding steps basically I am not going to go through, but you please, that doesn't mean that you don't have to go through. You have to go through, but broadly, basically, these are the different operations, right? So generating the RARP request message, broadcasting the RARP request message, processing the RARP request message, and then generating the reply message. So the server basically sends the RARP reply message and processes the source basically processes the reply message. So this is the internal details basically. Please go through yourselves and try to convince yourself. So this is pictorially, it is shown over here how the request is sent. Exactly the same kind of thing. Not exactly. The only thing is that it's reverse concept now, but it's very similar to how the ARP works. But so the question is that, let us say that you purchase a particular host, right? So you purchase a computer, your laptop, right? So when it has to connect to the internet, so what it will do is initially it is going to do some search, right? So it's going to look for the IP address. So it says that my physical address is this. You see this is this physical address in this format. So now it says that I am looking for my IP address. So this request is sent like this. So there will be an RARP server which is going to send the reply back, right? So it's going to send the reply back, but this RARP server is going to unicast to the host, exactly like we did in the case of ARP. The only thing is that over here you have this RARP server, right? So which is going to unicast it to the host, the IP address. The packet format for RARP very similar to ARP, and the encapsulation issue that I told you, so for exactly the same reasons that so the ARP packets are going to be encapsulated within the frames, the link layer frames. Here also the RARP request or reply packets are going to be encapsulated within the RARP frames. So that's all. So the differences between RARP, ARP are all given for you to go through. Disadvantages of RARP are also there. So, but remember one thing, that ARP is very popular. It's a must tool to know. It's a must protocol to know. RARP is more kind of like phasing out kind of thing, and so nowadays people use DHCP, which also follows the concepts of RARP. So to get the IP address back. So that's all, and so let me just quickly